Hey, welcome everyone. Thanks for attending my session on testing frameworks for infrastructure as a code. Uh, in today's session, we would look at the evolution of infrastructure as a code and its current state, how to perform testing for deployments and provisioning on infrastructure as code using Terraform, and then further deep dive into some behavioral driven design testing using some common frameworks for infrastructure provisioning. A quick introduction about myself. My name is Ramesh Mathikumar. I'm a senior DevOps consultant with the Global Financial Services practice based out here in London for AWS. I work with financial services customers and help them move the needle towards faster cloud adaptation. So, if you have to look at what's been happening in the area of automation, especially around infrastructure provisioning, you'd have to roll it back a few years to see how we, as in like most of the customers, were provisioning infrastructure. So most of the provisioning was manual or kind of, I would say, semi-automated with set of bash scripts or other type of automation available. And then once provisioned, there will be some kind of a manual or again a semi-automated configuration which goes to the form of service. And that's how it was for a long time. And then that gave birth to infrastructure as a code. And we have some really cool tools like Terraform, CloudFormation, CDKs, and so on and so forth, and a lot of configuration management tools as well. So currently, where we are today, okay, the infrastructure as code practice has been pretty mature. Most customers we speak to have some shape and form use automated provisioning, okay, and deployments. So it's a great place to be. What does this mean for the next stage? Okay, so where do customers want to be moving towards to? So that leads to the state which where people who are from the current state, okay, where they want to move to, which is like basically some kind of an orchestration which is available to orchestrate or choreograph the various infrastructure as code provisioning. Okay, so remember, like we already have automation available via infrastructure as code. So this part is about like being able to pull various what do you say elements of it together and then provision it. Okay, manage dependencies and so on and so forth. And then once they have provision, then validate some kind of validation, okay, using some automation engineering to validate that it meets the requirements, architecture, design, etc. And then finally, right, some kind of automation to configure what has been provisioned in and manage it in an automated manner. So this is the state most customers would like to go. Okay, and today we would zoom in into the automation engineering, the test engineering part of it, and see how we can apply some of the frameworks to help to achieve the validation part of what we are deploying. So when we look at when we look at the standard life cycle of provisioning, okay, so every one of us would have gone through this life cycle at some stage of provisioning. So we would have some kind of a requirement for which we would construct a module or a set of modules which would go and deliver a set of functionality. Those modules are your what do you say, a code or HCL configs to say, okay, and it could be for anything. And then those modules can be hardened using some kind of unit testing. Mentioned Terra test here. We'll look at a couple of options later. So this hardening will help us give good confidence about code coverage and that the code can stand up and deliver when it's called for. And then once it's gone through the hardening through whatever cycles, right, customers might have, it ends up in a controlled repository. Okay, so the TFE registry is a good place, but then you can have your own registries as well, right, where the source control is very very efficient, right, and you are able to pull one or multiple versions of the modules. So the life cycle then goes through, like, you are able to pull a version of this module and many such modules, concord it all together, and then go for a deployment. And each deployment would serve a particular business requirement, and the architecture associated with that, and the design associated with it as well. Once you have the confirmation that it's been deployed through your various CD pipelines which you might have, then you would have to run through a set of automated testing to ensure that, like, it's fit for purpose before you could go live with it. And then like, you could also do some benchmarking through some non-functional testing, right, with the tools available. So this is a generic life cycle, okay. And some of us would have done all the 9 yards of it, and like, most of us would have at least written some modules, right, push it onto the registry, use those modules and deploy it, and so on and so forth. So this is like something which is well aware, right? So if you now then have to zoom into testing, right, okay, of provisioning of infrastructure code using Terraform. As I mentioned in the previous slide, okay, TerraTest is a good option at a unit level. It's an open source framework. It's from Gruntworks. It's Go based. Okay, the way it operates is like, it basically uh, deploys the module which you, or the code which you want to provision, and then it could run through a series of tests, and then, like, once it does, right, it destroys all the resources. So you should have some kind of a sandbox where you could deploy and, erase your deployment. So that's a prerequisite for running this. If you don't want to use a sandbox and go into the complexity of provisioning and deprovisioning, etc., right, you could also use Terraform's native HCL commands to perform most of the stuff which you can do with TerraTest. So you could use something like Terraform checks, which is available from Terraform version 1.5 onwards. You can use custom conditions. You can use resource pre and post conditions to effectively validate the config. Again, as I said, right, the idea is, if you have a module, like, ensure that that there's 100% code coverage and the module can stand and deliver, right, when it's called upon, right? So that's the first part. The second part is like post deployment. Okay, what are the frameworks available to us? So Cucumber is one framework. It's a behavioral driven design framework. It's pretty common across automated testing in the industry today. Okay, and what it is like, it helps you write your test cases in a English like format, okay, which is called Gherkin. And this Cucumber framework is supported by many programming languages. There are many packages in Python which supports it, Java supports it, many languages supports BDD style using Cucumber. So you could basically kind of inculcate the Cucumber framework within some of the programming languages which your estate is used to, and then write effective tests, which we will see down the line, right, how to do some of them and validate your infrastructure, right? And then for the non-functional side of it, like, again, there are many tools available from AWS side. You could use the fault injection simulator to do the resiliency and reliability tests for non-functional testing. We also have the resiliency hub, and then, like, if you have any platforms, you could attach the platforms, right, including EKS, and then it tells you how resilient that platform is or how resilient that infrastructure is. So we got some couple of cool tools to help you with the non-functional side of things as well. Right. Okay. So a quick deep dive into Terraform testing. Okay, especially at the unit level. As I said, the TerraTest is a framework which is available. Okay, open source, and some of the patterns which like I have used, which I'm sharing, is like, one of the first things I would do is like code coverage. Okay, so if I have a like, say, provisioning resources for a module, then I would ensure that those resources are provisioned and they are basically, right, okay, if I pass the right parameters, then those resources are available and then they are in the right status, and so on and so forth. I could extend it further by going and looking at whether they are provisioned with the right config. Okay, for example, here's a DynamoDB table, which I'm basically like checking whether the DynamoDB table is active. Okay, the table status is active, and then my schema in which I define, right, matches my expected schema. So that's something which I can do over and above the code coverage. You could extend it to do some verification. Here I'm basically checking whether a subnet is public or private. Okay, and then like basically if I've designated subnets to be in the private, but it's appearing in the public subnet, right? Obviously, I'm going to cut short the test, right, and see how I can validate it. And then the final thing is like you could stage all of these testing in parallel or in sequence. Okay, and then you can easily orchestrate it. One thing to remember is like you might need a sandbox or an actual account to deploy this. Okay, and once you deploy this, right, you have syntax in TerraTest, which basically destroys it at the end. Okay, so that's something which is available to us. And if you have to perform something similar in using, using Terraform, the Terraform HCL has functions which supports it. As I said, right, you could use post conditions, pre-conditions, and other things. One of the things I want to concentrate today is the newly introduced check block, which, in my opinion, right, further enhances Terraform's capabilities to the testing side. So in the example on the left, I am basically calling a module. Okay, or let's say I'm deploying a module, and then like I'm basically checking if the output from the module is what I would expect it to. Right here, like I'm seeing if my certificate is in a issued status. And then if you can see, right, there's a warning which is telling me that the block assertion failed. And if you look at what I'm doing, right, I'm kind of checking for incorrect status. My status which I'm checking is issued 9 as against issued. Okay, so just to demonstrate that, like, you could extend it to check things in the right shape and form, and then like if they fail, you could use the pipeline and abort your deployment or roll it back to the previous state, right? Okay, so that's something which you can do. On the right hand side, okay, right, I'm checking a couple of data resources here. Okay, so I'm checking whether the deployment is the right account, whether the deployment is in the right region. And again, the same principles apply, right? If they fail and if you get a warning message, you could use the pipeline to effectively stop, abort, or roll back to the previous state, as it were, right? So these two frameworks, okay, would help customers to basically harden their HCL config at a unit level, right? So now what happens is like you would take these unit level modules, like basically assemble them into a deployment which delivers a business functionality, a business requirement, right, which basically matches to a corresponding architecture and design. So now what we would have to do is like validate the provisioning, right, which we have done matches to those requirements, to those architecture, and to those designs. So that's something which we need to do. Okay, like it's not good enough to basically harden the module at the unit level and then like basically not run any tests post deployments, because many things could go wrong. So we would have to continuously test. So BDD is one good style. Okay, so here I'm giving a very basic example. Okay, so I've deployed a VPC. So all I want to know is like, hey, have I got more than 2 subnets, right, for this VPC? So what I'm saying is, given VPC ID, when I look at the number of subnets, okay, it should be greater than 2, right? So that's my Gherkin definition. It's called a feature file. So I import this feature file into a Python framework, which is called PyTest BDD. So you could see that like I'm calling the feature file as publish article.feature. Okay, and then I'm saying the same thing as what it is, that VPC should have more than subnets, 2 subnets. And then I'm writing Python functions which exactly does that, just like how the framework demands to Okay, and I'm ensuring that there are greater than 2 or more subnets, right? Which basically means I have matched the architecture and the design requirements which that particular deployment needs. This is a very basic example, and you could extend it to as complex as it is. Okay, so you could use third-party packages, like say if you're applying a Kubernetes platform, you can use a Kubernetes package. If you're wanting some exhaustive test on AWS, you could use Boto3 if it is Python, right? And similar SDKs available in other languages as well. Many languages support Cucumber, as I said earlier. So you could use that language coverage along with the packages which are available via the various SDKs which I just mentioned, and you could elaborate your testing to like you could automate anything end to end. All right. The objective is this. So given you have deployed a particular business functionality by concording all these modules together, we should be able to independently validate whether it fits the requirement, architecture, and design, right? And then inform us back via some reporting that it is fit for purpose, so that like it gives the business the confidence as we move to more higher levels, right? In terms of like you move towards your UAT and production and so on and so forth, right? And in UAT and production, you can actually reduce the number of tests. Like you can run smoke test at UAT, and then in production you can run some sanity tests, and then ensure that like it's fit for purpose. So just to summarize, okay, we saw some of the how we evolved into the infrastructure as code framework today and how things are automated. And from there, we quickly looked at a couple of frameworks, one at a unit level and one at post-deployment level. So I would strongly encourage you to look at these frameworks and inculcate this into your pipelines. And if you have any questions, feel free to reach out to me. Many thanks for attending my session. Thank you. Bye.